It's already 7:10, and we can start the talk of this evening. So first of all, thank you everyone for coming to this talk. I'm Zheng Chang. I'm the chief scientist of the Codemao, and today I'm going to talk about science of the computation and coding education. And the basic outline of today's talk, we have like 6 parts. The first one, we'll talk about the imagination and creativity, because we are doing the coding education, so we need to understand the education better. And the second part, we're going to talk about the science of computation, a little bit of history about the computer science, and also the electronic computers, and also computational thinking. That's basically we're trying to teach the children to learn to coding and to have a kind of skills in the computational thinking to solve the problems. And the fifth part is about the machine intelligence, and sometimes we call it just artificial intelligence. This is also my main research area, and we will talk about intelligent society in the future later on. So the first part about imagination and creativity. And I think everybody agrees with that imagination is so important. Even Einstein has said, imagination is more important than knowledge, and knowledge is so limited, but imagination encircles the world. So when we talk about imagination, it's not like the delusion in our brain. So imagination is something like, as children, so we can actually receive a lot of the data from our vision system or hearing system, so we can have some memory, right? We see something, we hear something, and we can formulate the memory in our brain. And sometimes we can play the memory like a movie. So the thing is, when you play the memory, sometimes you can actually manipulate that, and you can fabricate something never existed before. So this becomes the imagination. And imagination is so important because that's related to the human creativity. And this is Sir Ken Robinson, who is a very famous education scholar in UK, and he gave a very popular TED talk about education on YouTube. That's one of the most popular TED talks ever. And he said, imagination, I believe, is what fundamentally sets us apart from the rest of life on Earth. And the creativity is very practical. So the imagination makes us a human. And the creativity you can consider something like a very practical tool. So just as I mentioned, we have the memory, we can actually change something and to make the memory like something that never happened before. That's the imagination. But how can you make your imagination into the real world products or into the real world masterpieces? And these are about our creativity. So for example, to say Steve Jobs, and Steve Jobs has seen a lot of phones. They have seen different kind of electronic stuffs, and he actually has the kind of a very particular imagination about what kind of a phone it should be, and then he actually lead the whole company of Apple and made it like a real, make a real phone. So this is how iPhone. So we can say iPhone is very creative, but this kind of a creativity comes from his imagination first. So that's how the imagination and the creativity are related. So in terms of about education, so we always want our children to have a very strong creative skills or have a strong creativity. So that's the reason we emphasize on the imagination for the children. And this is the kind of computation I used to serve as a judge. And you can see the left-hand side is a picture about one little girl and one boy. And the basic computation is they give these children some very useless stuff. For example, that time giving them kind of like a swimming ring, and also some papers, and also some decorations. And this the little boy and the girl, and they actually showed us their work. The work is about the kind of alien spaceship. Yeah. So you can say basically the children are kind of living in their own imagination. So they consider the swimming room as the spaceship. They have designed a different kind of decoration as particular, I don't know, masterpieces, whatever. They just organize everything together. Then they have a story to tell us what happened and what's the function of the spaceship or something like that. So basically, they are kind of immersed in their imagination, and that make the human being so different from other lives in the world. And also, I will mention that the imagination is also the one most important reason why the humankind dominate the world. And the right hand side is a painting. The painting, maybe you can see like a spring days, a lot of people trying to gather on a very high bridge. But on the other hand, this painting just a few scratches, a few lines and a shade or something like that. Why you can imagine there's the bridge and a lot of people there. So it's not about the painting itself. So all these scenes exist in our brain. So we're using the imagination to see the picture or to see the painting. So that's why the imagination is so important. And in terms of psychology, and we have like 3 levels, and usually called the ladders of cognition. And this ladder has 3 levels. The first one, so it's about the association. So the people can see something, they can observe the your surroundings, and you can make a kind of association and to make some very simple decisions. And you can see the animals, yeah, and different kind of animals. They react based on their observations, and even today some very simple artificial intelligence programs and robots, they can actually observing and react. So this is a very simple way, a very simple level, a very low level of about cognition. A second level is intervention, is you can do something to change what happens. And our aboriginals or even baby, they have this kind of skill. So they actually observe the world and they know you are part of it. You can intervene the things that are happening and that can change the consequences. So this is the second level of the cognition. Consider the last one, maybe the highest one, is about the imagination. So we can have some counterfactuals like what if something has been done, or what if not something has been done. For example, what if Donald Trump was not elected as the president of the United States? What will happen to the world, or something like that? So this is kind of to understand this kind of mental activity is about our imagination. So imagination is the reason that mankind dominated the world, because we can consider about intelligent individuals. The chimpanzees it's not that bad. They can actually do a lot of things. They can using the tools to help them. And if we consider the collective intelligence, the ants and the bees, they can actually coordinate together very well. But only human being, they are kind of individually intelligent, but also they can work in a very collective way. So that makes the humankind different from other lives in the world, and that's why we can dominate this world. And so the second part, we'll talk about a little bit the history about computer science and how computer science will help us to reshape our imagination and creativity. We'll connect all these things together. So first of all, we mentioned that computing has a very long history. Even as aboriginals, they need to calculate counting the days to calculate how many food they left or something like this. So in ancient China, so we have a very old computing tools called Abcus. I think a lot of people know about Abcus. But even older than that, so in China, very ancient China, we have like the computing stakes. They're just like the stakes made of bamboo or wood or animal bones. So they can store it in a bag and they can post different structures. And different structure means the 1, 2, 3, all these numbers. And they have a different kind of rules to do the calculations, like the abacus. So the Chinese people, we were using the chopsticks, and then I think not many people heard of the computing sticks. But yes, we do. We do have a lot of the sticks because we are I think our ancient time in China, they have a lot of the forest. That's the reason that we can make sticks very easy. So we use that for food. We use that for computing as well. In Europe, that's another story. And I think that's the first calculating machine made by French mathematician Pascal. So we call the Pascal computer. And this is like other machines at that time. So they were using wheels, using the gears, and to do the calculation. But one thing, they can only do the addition, not subtraction or multiplication or division, all this stuff. And they're doing the subtraction in a very interesting way because they can only do the addition. So they're using the complex numbers. So I'll explain what is that for. For example, you want to calculate 12 minus 4. 12 minus 4. And because this machine cannot do any minus, so they change that into the addition. They're not, instead of minus 4, they just add the complex number of 4. Suppose we're using the 10 as the sum up to 10. So the complex number of 4 is 6. So instead minus 4, we add 6. So we got 12 add to 6, we got 18, but we need to take out 10 from them, that will be 8. So we got a final result like 12 minus 4, that equals to 8. And using that way, we can calculate even more complicated, like minus and multiplication and something like that. So this is the first machine, calculating machine using the metal. Yeah. And now let's talk about the coding and the program. And this is about the year after Christ 60, and this from the hero of Alexandria in Greece. You can see that the very intelligent small cart, they got different weighting system, and the cart can go straight forward and turn around and go back. And this is, we can consider this one is the first programmable machine. And also that change our mind or concept about programming. So programming is not only just using the keyboard to give some like a Python code or a C code. Basically, coding is the way to tell machine what human want them to do. And that's considered to be very early stage of the coding or programming. And of course, I think somebody very familiar with the music box. And the music box, they're just using the handle. They can actually play different kind of music. If you actually open the box, you can see a revolving cylinder, and you have many pins on the cylinder. And these pins can, like a nail, they can actually pull off the string and play different kind of notes that will be formulate a particular music. And if you want to change the music, you can just nail down these pins or maybe pull off some other pins. So you can change basically the pins distribution on this cylinder, and then you can actually play different kind of music. So interestingly, you can see that if you nail down the pins as 0 and you pull out the pins as 1, so that will be like in the cylinder there are a lot of 0 and 1s, right? And this 0, 1 actually defines what kind of music you are going to play. And this is exactly like what we're doing right now in the modern computer. We use 0 and 1s to program the computer to tell them what to do. And this is the early stage. So I think about 1970s. So about the I think 18th century. So the first one, the first kind of modern computer was built by Charles Babbage, who was served as the president of the Royal Society in England, and he made a difference machine only for scientific calculation, because at that time the calculation demand is higher because they are trying to calculate more complicated physics movement. For example, to say how can we calculate the orbit of a particular planet like Mars or Jupiter or Mercury. So they need a very complicated machine to help them to do this calculation. And Charles Babbage came out with the idea of using this very complicated machine. It's called a difference machine. And later on, they have a higher level of this machine called analytical machine. But unfortunately, this machine can never be formally built until his death in 1871. But about 100 years later, and the scientists in the London Science Museum, they're using the modern technology and also using the designs and the drawings left by the Charles Babbage. They make a real analytical machine, and right now it is still in London. And that picture was taken in 2008. So when I was visit the Science Museum of London, so I was so impressed with this kind of very huge machine, and they can do a lot of very complicated computation. And the inventor has been dead over 100 years. He has never had the fortune to see his machine has come to real. Yeah, and then after all this stuff, we come to the modern society, and we have, because developing the science, especially about the physics, so we can design some electronic computers. And right now, all this kind of all the computers we are using right now are electronic, right? So that's how the electronic computers has reshaped our society and our world as well. So before we talk about the modern computer, so we need to mention one scientist, Leibniz, and he's German, and I think many people know about him. He's German, and he has reputation to with Isaac Newton to build the calculus, to invent the calculus. You can see that. And he also was one of the mathematicians looking into the binary number. And there was some story about Leibniz, and he has a friend from the east, maybe from China, and he actually gave him a kind of you can see the symbol in the middle. In Chinese called Bagua. It's actually kind of a very ancient Chinese philosophy, and using the symbols to tell about the directions, to tell us about the elements like water and soil and fire, this something. So in all the Asian philosophies, they consider everything was made up by these very basic elements. That's also the same in China as well, but differently. So the Chinese have a kind of a symbol. This symbol, I think some of you may have seen that in even the Korean national flag. So this is a kind of a yin and yang, and they're using the 8 different kind of symbols to represent different directions, like south, east, and the west, and the southeast, and the northeast, and something like that. And we got 8 symbols. You can see that. Then each symbol, they have like a line and a broken line. So if you consider that the one line is 1, and the broken lines are 0, so you can basically, these 8 symbols are just binary numbers from 000 to 111. Yeah, so that gives the Leibniz a lot of a hint about, maybe we can using the binary numbers, we can use the binary representation to vector numbers. And later on, the George Boole, they actually using these binary numbers to do the calculation, because no matter it's like a decimal, no matter it's a decimal number like 1, 2, 3 to 5, or binary number 0 and 1s, they can do the normal calculation and arithmetics, right? That's the same. But there's one interesting thing, because if you consider the 0, 1s, they can do the logical operation as well. You can see down there, we can do AND, OR, and XOR, or this kind of logical operation. So George Boole, they invented the Boolean algebra. So they're using the logical operations to represent the normal calculation, like addition, subtraction, multiplication, division, and this stuff. So once you have this basic arithmetic operations, you can have all kinds of calculation. So in that way, so all this complicated calculation can be done using this logical gate. So we have the logical circuit, and later on, because the development of the modern physics, we human beings find a semiconductor. They have very particular properties, and using that property, we invented the transistor. So the transistor actually reshaped the whole world's industry, and the whole Silicon Valley was built on this basic innovation. We will talk about later about the Silicon Valley, because Silicon Valley has fostered a kind of very unique culture of innovation and entrepreneurship. So I think before the Silicon Valley, if you're trying to be rich, you have to be a businessman, right? Or you have to be a noble or whatever, to be a priest. But after that, people just realize that if you are a scientist and you have a creative idea and you can design something never existed in this world, you can make a big fortune from that. So the Silicon Valley is not pure just a business. It's actually give a lot of young people a new hope, because you can actually learn a lot of new technology. You can design something never existed before, and you can start an entrepreneurship. You can start a company. You can make a bigger fortune. You can change the world. So that's basically Silicon Valley culture can help this world. And based on that, and we can using a lot of transistors into one small chip. And this small chip, we have a different kind of functions. So basically, just like you have a particular input, and these inputs are just ones and zeros, and you have one output. The output and input, they need to fulfilling some very complicated functions. So we can using these logical designs to finish, or using these logical designs to resemblance this kind of function. And then this is the first time we can design some electronic chip, and this chip can operate very complicated kind of processing, and that make the information age come. Later on, so people just realize that we need a small chip. We need that to be faster and also to be more complicated, because we have a complicated demand about the computation more and more. And then some very brilliant engineers, they come out with a new idea about how can we design such a very complicated chip. If you're trying to put like 10 transistors into a chip, it's not that difficult, right? Even you put 100, you can make the transistor smaller. That's still okay. But if you're trying to put 1,000,000 transistors into a small chip, right? That's so difficult. So, and the Gordon Moore and the Robinois, they come out with another way, just like like the carving in sculpture. So we have a one chip of silicon, very high density, very pure silicon. They're just trying to use a laser to carving the unnecessary part out, and the rest of them just like 1,000,000 transistors, a combination. So this is the kind of way. So we have developed the multi-scale or large-scale integrated circuits, and that become the fundamental or innovation, and also the very basic part about the central processing unit, the CPU, or any other communication and computing chips today. So the Intel, so these guys, and they start a new company. They call it Intel. So far, Intel is still one of the biggest such IT companies in this world, and they still making a lot of very expensive chips. And these chips can actually do a lot of things in our smartphones and in computers and television everywhere. So we become an information age, and of course in the computer as well. And the original electronic computer is so large it can fall into a room. But later on, we have the desktop, we have a laptop, we have the smartphone today, and you can see that the computer becomes smaller and smaller. But the power of computer becomes much stronger and stronger again. So you can see today you carry a smartphone in your pocket, but that smartphone is so powerful that's even much better than the very old classical computer, which is big as one room. Yeah, so this is a very rapid development of the electronics industry, as well as the computer industry becomes the information technology. So that's later on we have the internet, we have the software, we have actually the mobile network, we have the smart app, so we have the smartphone, so we got everything that's become what we are today. And now, so this is so previously we talked about a little bit about the education and also a little bit history about the computer science. and why we need to learn the programming, or why we need to learn coding. And today I'm going to talk a little bit about the computational thinking. So before we're going deeper, so we have to mention one important guy, Alan Turing. Of course, I think everybody knows that Turing was the founding father of the computer science, but also he is the founding father of artificial intelligence as well. Yeah, and he actually worked for the British government in the Second World War, trying to break the break the German code. And you can see the tombstone of Turing. That's very interesting. They mentioned that he was born in 1912, but died in 1954. So he only lives about 42 years. And died about 42, and he is the father of computer science, and he also a mathematician, a logician, also full-time code breaker. And the last line was he was also the victim of the prejudice. I think some of you may know about the Turing's life, and he was a gay, and at that time the gay was like committing a crime. So he was kind of being committed to be guilty by the British government at that time, and he was forced to using some kind of a medical treatment, and that caused some depression, and he finally killed himself by biting a poisonous apple, and died on his 42 years. Yeah, so that's a kind of very sad story. But Turing has left a lot of things for us. First of all, he published a paper about the computing machinery and intelligence, and the first time he proposed the question about can machines think? And after this paper, so we have formulated particular mental experiments called the Turing test. So, for example, consider in a room, the door has been shut, and there could be a human, either a computer, but you have no idea who they are. And there's an evaluator outside. They're using a kind of pen and paper, and you can write a question and slip it into the door, and they give you the answer. We have no idea it's a computer or a human. But if you evaluator, you cannot tell the one give you the answers are a computer or a human. Suppose that's a computer, so the computer passed the Turing test, because a human being cannot distinguish from a machine and a human. That makes this machine very intelligent. And okay, and if you have ever watched this movie, The Imitation Game, it tells something about his life and also his work as well, and especially in the Imitation Game. So they're trying to answer can machine think? Also, okay, the Turing in the movie, they mentioned to say, you are asking about if the machine can think. Oh, of course they cannot. If you say the thinking in a human way, right? Because the machine is not human, so they cannot think like ours. But thinking cannot be defined in just one way, right? For example, to say our human beings are very intelligent, that's through the evolution over the millions of years, we have very intelligent brains. So human beings can actually solve a lot of the problems. But maybe this is not the only way to solve this problem, right? We can use something like a based on the math and also logic, right? We can use some engineering approach to solve the problem as well. We can also make very smart decision making, but maybe not in the human way. So that actually gives a very important philosophy about artificial intelligence. So far, we have a lot of research and different kind of improvement in the artificial intelligence technology, but we are basically using the engineering approach, because basically we know exactly what's going on inside. These are just the code. These are just the zero and the ones. These are just mathematics and the logic. So we are using complicated models and to solve the problem. So just like, we're trying to fly for all the time, right? Even very early times, so our ancestors see the birds can fly in the sky. So we have invented a different kind of machine with wings trying to fly in the sky. But actually, we haven't succeed. Yeah. But later on, we can fly into the sky and we have aeroplanes. But that's because we invented the aerodynamics. We understand this physics and also the science behind it. So trying to fly, there's not only way of using like the birds have the wings, right? We can be using the plane. So basically, for smart decision making, also trying to solve these very complicated decision making problems, the human way may be not the only way. So that's the reason give us a lot of hope. We can use the engineering approach, using the mathematical models, and to do this kind of intelligent system to help us human beings to be more comfortable in this modern time. So this is about the basic idea about artificial intelligence as well. Okay, so talk about the computational thinking. And this is a very popular topic in recent years. And so a lot of the scholars and researchers kind of recommend the children to learn the coding at a very early age, maybe like 10 years old or even a little bit younger than that. So at that age, they can understand how we can interact with the machines. So the computational thinking and the Google actually, they have like they have a different kind of definitions. So Google has a definition about the computational thinking is about decomposition. To have a complex problem, we need to decompose this big problem into smaller ones. Abstraction, you have the real world problems, you need to abstract that using some particular mathematical model. And pattern recognition, how can you can understand the very complex signals like images, the videos, and all the speeches or something like that. It's called the pattern recognition. And the basic to solve these problems are the algorithms. Algorithms is like a particular way to solve a particular problem, and it's like a solution. So we can, if we actually trying to train the computational thinking, we can consider this four parts. If we can decompose a bigger problem into smaller ones, and how can we design a particular mathematical model to develop a new algorithm to solve the problem with the complex signals or something like that. And this is the computational thinking, but this idea is actually have a long history. Give some examples and about the algorithm. This is about the Hanoi Problem. I think a lot of people have know about it. So we have different wings with the different size, and we need to move from the first bar to the third bar, but we have to follow the rule that the smaller ones is always on the top of the bigger ones. Right? So if you're given the three rings, that's not difficult to solve. But if you have more than 3, 4, or 5, or even more numbers, that make this problem very difficult. So I think many of you know that the problem has a very high computational complexity. So the computational complexity is increased exponentially with the number of rings. But we can actually solve that problem into just like 5 lines of code when using recursion, right? So consider, we just consider, for example, given the 4 rings, we can consider the 3 on the top just like 1 ring. Then you can just move the 1 ring into the middle and to make the biggest one to the third bar, and then to move move the 3 altogether from the middle bar into the third one. So this is a way to solve that problem, and this one can be solved recursively. And this is actually one way of doing to solve that problem. But what I'm trying to say is, consider if you're a human being trying to solve that problem, you can find it very difficult, right? But using a computer, they can actually have the different logic, a different way to handling this kind of problem in very easy way. So this is why we're using this kind of recursion. And talking about algorithms, I will talk about the stable matching. And this is a very interesting problem. So suppose we have boys and girls, okay? We have 5 boys and we have 5 girls as well. And each one has a prereferences list. For example, the girls are called A, B, C, D, E, and the boys are just 1, 2, 3, 4. And for the boy 2, so for the boy 2, they like the girl A the best and the girl D the least. And for the girl B, they like the boy 5 best and the boy 3 least. So just like, we have, everyone has a preference list to choose, which one you like best, and second, the third, and which one you like least. And then suppose we know all these preferences list, and suppose you are a matchmaker. How can you pair these boys and girls to make them couples, and the overall satisfaction is the best? How can you maximize the overall satisfaction? And this is a very classical problem, right? So this is called the stable marriage problem. So in all the society, the marriage is always it's a big problem. And other than that, you can consider the students go to the college, and the college wants some particular good students, and also just like the job market, the company want the best employees, and all the people want to go to the best companies as well. So all the scenarios about matching. Sometimes just one-to-one matching, like this marriage problem. Sometimes just like a one-to-n matching. So it's just like one company, they need to hire 10 or even dozen of the people. So this stable matching problem has been solved, or just Shapley and Roth. Basically, Shapley and his friend David Gale, they proposed an algorithm called the Gale-Shapley algorithm to solve that problem. And Alvin Roth has been actually working on this field after them, and they solved a different kind of like kidney exchange problem or something like that. And finally, they won the 2012 Nobel Prize for this kind of a contribution. So I'll give you a brief about the Gale-Shapley algorithm, which is very simple, but can solve this very difficult problem. Suppose you have all these guys and the girls, right? And first of all, the first step, you just random to pair each one. So you have 5 random pairs. And if there are 2 pairs, they have the following condition. We call them like the blocking pair. What kind of condition? Just like, for example, you have your girlfriend, another couple, you have one guy, another with his girlfriend. But you like his girlfriend better than yours. But same time, your girlfriend like the another guy better than you. So 4 of them, just like the 2 couples, two guys, 2 girls, and each of them want the opposite. They want the other, your opposite component rather than your current partner. So if that is the case, so you can easily switch, right? You can swap, you can switch. Then you have so everyone has more satisfaction. So I'm not sure you follow me. So randomly we can just pair each person. We got like different pairs. If there's a blocking pair, the blocking pair is like everybody likes others' boyfriend or girlfriend. Then 4 of you can actually all agree to switch. Then everybody become happier. So in that time, so in that case, we can just from random. So for each 2 pairs, it doesn't exist any blocking pairs. So if you find that 4 of them are trying to switch, then you switch. So until nobody has any motivation trying to switch your current partner, then the whole system becomes very stable. So this is about the stable matching. So this very simple algorithm can solve the very complicated problem in marriage market, and job market, even for the students in the college problem. So this is actually the fascination about using a very smart algorithm. And then about abstraction and simulation. So on the left, there's a very interesting research recently released from the OpenAI. And this is about hide and seek. So a lot of children play the game hide and seek. These red guys are just the seekers. And these blue guys are trying to hide from the seekers. So the game starts. So the blue guys trying to find some place to hide them. And the seeker's problem in trying to find them all the time through all the difficulties of trying to find all these blue guys. But we have a kind of a special environment. And we can do gradually, they're learning from the environment. So the hiders, these blue guys, they learn to hide into a smaller room and using these boxes to block the door. So in that case, these red guys cannot find them. So this kind of skill or this kind of cognition is kind of automatically involved. So we just give them the feedback from the environment. They do the simulation over the millions of times. They can learn a particular strategy, and this strategy will help the hiding seeker, the hiding agent, the hiders, to be safe. And later on, with the more kind of a trial of the experiments, these right guys can develop some very special skills, like they can use this ramp. So these right guys, they learn how to use this ramp, and they can get over of the wall, and they can still find these hiders. So this tells us how the animal behavior can evolve through the environment. So the agent, and no matter you are seekers or you are hiders, they all become more intelligent with the involvement. Okay, and the simulation is like you're trying to play any game. You have to design every part and to make sure everything is so clear and everything is logically connected. So in that sense, the computational thinking has a little bit long history. Even in the 1980s, Seymour Papert, they proposed the Mathland. So what is the Mathland? For example, if you're trying to learn English or trying to learn French, right? If you're trying to learn French, the best place to go is France, right? Because they have a language environment. When you speak a language, you can interact with the environment. You can get feedback very immediately. That can improve your language skill very much. But if you're trying to learn the math or logical reasoning, all this stuff, logical thinking, can we find such an environment? And he actually designed a particular robots and, tell these robots in a particular room, they create such a kind of environment for the students. But now, today, we do have such a kind of environment. We can do that in the virtual world of programming and coding. For example, if you're coding in a particular language like Python, right? You can tell the environment what you want to do. And if you wrote a particular line of code, and the code will give you immediate feedback from the environment. So basically, you're doing the coding, and you're trying to doing some experiments in a virtual of a Mathland. So this is why coding is so important, because we're trying to interacting with this Mathland, and that can reshape what we are thinking logically, and can help us think critically, and can help us to think critically, and also logically about this virtual environment. So we believe that Seymour Papert's work is very important, and that's also the reason today I think the children should learn some coding, because through the coding they can learn how to do the logical reasoning, they can learn the mathematical sense, they can actually to see this kind of ideal abstraction world, and how can we interacting with this kind of very perfect abstract math world. Okay, and of course I think another important reason to learn the coding is because the artificial intelligence and machine intelligence, that has been playing more and more important role in our society. And of course, that no matter how smart the program are, but these are just lines of code, right? For example, this is the Python code. This is, I think, that's the Java code, right? This is the Java code, and each Java code you can consider like a particular gearing wheel in your machine, right? So we understand that if you are an engineer to design a car, we know how car can run, right? We have many gears. They were biting each other, right? They were encaving each other so they can move together to make the car running. But actually, when you do decision making or do the information processing, it's actually the same way. because we just mentioned we're doing artificial intelligence in a very engineering approach. So each line of code, they tell you exactly what should you do. And this code, each code, just like these gears, they're trying to, engaging each other and to move, and then finally you can have a decision. And this is basic artificial intelligence as well. And of course, today's machine learning, especially the deep learning, has developed. So we have many new applications using all the information we have. For example, the speech processing or speech recognition. So we can have like intelligent intelligent assistant like Siri from iPhone. So we can talk to Siri, so what time is it? I want to make an appointment or something like that. And also we have the very smart search engine. We can input the query in natural language. We can have the image back, and also we can input image. We can find some natural language description about the image as well. So all this multimedia information, no matter natural language text or images or videos, we can process them into the numbers. We can using this very complicated mathematical models to process them and give us the recommendation or classification or prediction. And in the real world case, I think everybody knows about this AlphaGo, and AlphaGo actually has changed the world about our views about artificial intelligence. So at this age, we really understand artificial intelligence is so important, and it really changes the world so much. And actually, so considering being an artificial intelligence researcher, so the development of AI is like a line. So it has been developed for the past 2 decades very smoothly, but the society or the common people have no idea what's going on about this kind of a scientific research. But AlphaGo really shocked the world, right? The whole world knows that, okay, machine can do something so magnificent that has been so out of our expectation. They can do something so smart, right? And that makes artificial intelligence more popular. And a lot of the different kind of research and companies, they're looking for AI people. So that's the reason make AI so popular and make it very, very good paid jobs or something like that. And another important research area of AI is computer vision. So this is the example that's the research from my lab. So we're trying to link not link, just find out the relationship between the lines and the color. So if you're using some sketch and you need to paint it into a real animation, so you need to make them color, you need to paint them. If you draw some different kind of figures like that, you can immediately find out, okay, this guy has to be yellow and the pants has to be blue, because we haven't seen so many such things in our training data. So we know that this kind of a sketch has particular relation with color, but this kind of relation cannot be described in equation, right? In the physics, in the 18th century math, so basically the science is about using a mathematical equation to describe the world, to describe the nature, to understand nature, how nature works, right? So we have different kind of equations, but so far you find there's some relations are too hard to be written into equations. Then we develop these kind of mathematical model or machine learning models, trying to learn the relations between the sketches and the colors, trying to learn what's the differences between the one image from the morning to the night, to learn the relation between this map color and the real picture. So yeah, we all need to pair up different kind of input and output and trying to find out all these relations are. So this is about the machine learning and computer vision. But we can go beyond that. This computer vision, the AI has been, greatly helped the different kind of also reshape different kind of industries. So one of the very promising field is about using the AI technology in medicine or in the medical science, and this work is about using using machine learning to find out who is the okay. This is about digital pathology, so I'm not sure everybody is familiar with pathology. This is like the image in the cell level. Suppose you go to the hospital, you find yourself uncomfortable. Sometimes if you have the tumor, if the doctor suspect you have the tumor, you have to do this kind of a test. And you have the picture. You can see the two lines above there, there's the two rows. These are just kind of benign tumor. And down there, kind of a bad tumor, a malignant tumor. So this is supposed to be the cancer. So we can use our image technology to do the classification. Suppose the patient, they take all this examination and have this pathology images, then you can do it automatically to judge if this one has a real cancer or not. And also, if you're given the image, they can actually search through the database to find out, which is the most similar images to your condition. And of course, that image has been diagnosed by other doctors as well. So this could be a very good references for your disease. So this kind of a system can really help the doctors to improve their efficiency, to help the doctor, so in some way to help the patients, to solve that problem. So the AI system in medical area, so sometimes people are trying to say, so maybe one day the doctor will lose their job. We're using AI to make the diagnosis, but actually it's not true. So we're using the AI system to help the doctor. It's called computer-aided system to help the doctor to make decisions very quickly and accurately. So that can help the human, help the patient as well. So just like today, the coronavirus, recently in America, they developed some very quick way to do the testing, so they can help a lot of people by improve their efficiency of the test. Okay, and because the limitation of the human cognition is the fact, our human has the emotions, so we can not make very objective decisions sometimes. So behavior economics tells us humans are kind of irrational, so are very vulnerable to mistakes. Daniel Kahneman also won the Nobel Prize in economics. He developed an area called behavior economics. Behavior economics means the human behavior is not irrational as we assumed in the classical economics. The human usually acts irrationally. So this kind of irrational thinking make a human very vulnerable, but machines are not. Machines are code. They can actually make a very cold decision, very smart decision based on the data totally. They don't have any emotions or empathy, so they can actually they can make rare mistakes. So right now in the internet industry, if you actually design a particular page, right, you need to try the A/B test to see, given a particular bunch of customers, they like A better or B better. So just based on data, they can decide we use plan A or plan B. So that kind of decision making, we can just consider as like from the view of God. So because people, if you want to make a decision, you cannot look the data for like a million of the customers, right? One human cannot do that, but a machine can do this. So the machines can actually summarize the data from over a million or 10 million customers and make a very smart decision, but code decision. So today's industry sometimes you mention to be data-driven, because data-driven is very objective, and they can actually be smarter than human decisions as well. So I think the ideal situation is like the human plus machine, so we can actually work together to make a much better world. So we need to actually realize that we human beings indeed have very serious limitation. That's the reason we need artificial intelligence to help us. Okay, so in the future, we are going to step into the intelligent society. No matter you believe or not, it is happening. So consider about the future, we consider about today, because today is the future of yesterday. So these two pictures is about like a half century and a 1 century ago. People trying to predict what today will look like. Yeah, and the first picture You can see about half a century ago, people trying to imagine that maybe in the year like 2000, people will have like a newspaper television. That means you can watch newspaper, you can read the newspaper by watching television. I think that has come true, right? You can browse any news in your smartphone. And the right picture is about a century ago, and the people, they wear a very big, like a radio thing, right? And they have the mirror on the hand, so they can actually talk to the relatives and the friends in remote. So this is like the video call we have today in our smartphones. So these two dreams has come true. Yeah, because of the information technology. So if we summarize the development of the technology, basically we start from design the tools manually, and we can actually design some mechanical machines. From mechanical machines, we will have the industrial automation. So I think all the things, the product you can see today, like cars, like your seats, computers, and everything, and most of them are from the industrial lines. So this is about the automation. And with the more advancement of the technology become information. Just like about 10 years ago, we can have a computer and we can use the internet trying to exchange the information using the email or using the or browsing the YouTube or whatever. And this kind of information change that make us go to the information age. And of course, the computation is ubiquitous, and that is also happening. So the computer science previously as the kind of profession, we still have the kind of major in today's university. But if you can have a close watch, you find that no matter you are studying physics, chemistry, or engineering, or even neuroscience, you have to use computer, and that makes coding so important. Because right now the computing or coding is part of everyday life. It's not just like one individual branch of the research field. It's actually already dissolved into everybody's life. So you have to learn to coding to do your research, to finish your job, or to do everything. So that makes the computation ubiquitous. And also, finally, I want to mention something a little bit different, is because that maybe help, computing or algorithm can also help us to understand nature better. Why? Because all the science, all the development of science is trying to understand the nature. The way we're using is about using the mathematics, right? We can use mathematical equations to explain how nature works. But you find out, the life, the creatures, the life is also a part of nature, but it's hard to be described by a mathematical equation. Why the tree looks like that, why the pine tree's leaf are different from maple trees or whatever. So this kind of natural phenomenon cannot be explained so far by any particular mathematical equations. So Leslie Valiant, he also proposed this like the ecorhythm, to say why the evolution or ecosystem has become something like this, because they have some particular algorithms. So he gave the new name called ecorhythm. They even consider the universe, they have some particular algorithm behind. So we have a kind of a computable universe. So algorithms can be a very well complement to the current math or current science. So by using the science we have so far, and if we're using algorithms in computing, so we can understand the nature maybe much better than we have before. Because you haven't seen that the computing or algorithms, they have more power. Also, you can mention that they have different powers from the current mathematics can do. So we still have this is still unknown area. So we really hope that maybe we can have some breakthroughs in the next few years, and to see if we can actually using some very interesting algorithm to explain why the bacteria or our neuroscience or our consciousness or something like this. So this is still left a lot of areas to explore. Yeah. So this is the age of human and the machine coexistence. So you agree or not? So we're basically trying to we are stepping into the kind of intelligent age. Sorry, the intelligence age. Yeah, and from the manual labor to mechanicals to mechanics to the automation to information age. So far, we're going to the intelligence age. That age is actually the human and machine coexistent. And how do you define one person's skill? It's not only about this one person. It's about how this person and how he can use or she can use the computer to finish the job. So we are inseparable from the machines in the future. So that's the reason we have to learn how to communicate with machines, how to use machines, and how to let the machine do what we want to do. So all these things we are through the coding, right? And also coding is just like we have mentioned before. It's like a kind of a virtual environment. So we can actually, in our coding environment, we can do what we want, and we can, from our imagination and using the coding to make it into the real product or to the real stuff. And this is kind of how we exhibit our human creativity. So this is how this everything has been connected. So basically, we're going to the future with the human and machine coexistent. We need to learn how to communicate with the machine and work with the machine. That's become coding is so important. And coding is actually one of the fundamental skill we need, trying to put our imagination into the creativity to design something never existed in this world before. And that's how human being can still dominate the world. We are trying to be better, and that's how the technology has been advanced, from generation to generation. And finally, the future has come already, and this is the funeral of robots in a particular time point in Japan, because we have this Gboard like a dog, a robot, and they have different generations, and these robots cannot be repaired because some pieces are no longer being produced and provided so far, and the owners are so sad, so they want to organize a kind of a funeral for this robot dog and their pets as well. And they actually organize such a kind of robot dog funeral in the temple. And I believe its owners are very sad about that, right? So we do have the emotions. We have the emotion attachment with these machines. And this thing has already happened. And right now we are already in this intelligence age. I'm not sure if you are ready. Okay, thank you so much for listening to this talk, and I'll be very happy to answer any questions you asked. Okay, do you have any questions about this talk? Yeah, it's about an hour. So we still have a few minutes to answer the questions. I'm sorry that could be a little bit fast because I have a lot of slides, so yeah, I'm not sure if any place you are not very clear, and I hope you understand. If you want to know more about it, please ask the question. I'm not sure how many of you are online, and if you have any questions, just let me know, please. Okay, someone has asked questions. Since computing has changed our world and AI will continually change it, what age do you think appropriate to start coding? Okay, yeah. All right. Yeah, that's a very classical question. And usually we believe that by starting coding, we can start from like a graphical coding language like Python or Scratch. So that's actually for the beginners. And we can start usually from 9 to 10 years old. That should be a good stage to start the graphical coding language. If you're trying to use Python, that should be a little bit older, maybe like over 13, like over 12 or 13. That will be the good age to start using the, the real code. Okay, and the AI based courses, and yeah, I think today many people trying to develop different kind of AI based courses, but this is pretty hard. And you can see there are a lot of online classes in machine learning and computer vision as well, but these are for professionals. They're not for adolescents or for children because AI is still a very advanced technology. If you're trying to understand the essential part of AI technology, you have to know calculus. You have to know the linear algebra and the statistics and all this stuff. You have to be a college student to learn the calculus, right? So this is pretty hard. But some people are trying to make it easier. We're using some like a sealed blocks, use some modules, right? This module about face recognition, and this module is about speech recognition. So the children just can put all this module together to design a new system. And this is the way to learn some AI-based courses. Yeah, and basically in the Codemao, we also offering such kind of modules in the kitten, and you can try that. So this is pretty easy. So you can have a different kind of blocks or this using these blocks, so you can just stack together to make a program, and they can actually finish. They can actually do some very complicated functions like the face recognition or something like that. Yeah, yeah. I do have the suggestions as I mentioned about AI learning. So if you are trying to be a professional, so if you are not children, you're adult, you have to learn, one by one to learn the math, have very good mathematical foundations before going to the real AI classes. But if you're children, right, just I mentioned, you can use the modules. So at this age, there's no way you can understand the inside the math about, how the computer recognizes all this stuff. But but the thing is, for example, you can use a PowerPoint to design your slide, right? But you cannot write a program for the PowerPoint. So you can use that. So for children, so you can learn AI by using them, but not trying to understanding the very basic ideas, even the math behind it at this stage. That's still too early. So you have the mathematical foundation to do so. So far, that's too difficult for children. Oh yeah, why I choose the computer science? That's a very interesting question. So I didn't choose that. So I just kind of gradually become a computer scientist because in my college years I choose the automation control, automatic control, automation. This is still kind of engineering stuff. But at the fourth year, and when I start doing some my final year dissertation and a project, so we need to design some particular we call the smart or intelligent system to control some stuff, right? And that make me very interested in the algorithms and all this kind of very interesting math behind it. That's the reason I decided to do the master in computer science and artificial intelligence. And also I did my PhD in this area as well. So I gradually diverted from engineering to the computer science to study the pure algorithm, but not the mechanical stuff. Yeah. Yeah, the fourth question is about the Codemao. There are differences between the Codemao's Kitten and Scratch. And yeah, the Codemao is the company, and we offer the language called Kitten. Yeah. Your question is about what's the differences between the Kitten and the Scratch. Scratch is actually developed by professors from MIT, and that's well used as well. I think everybody knows about Scratch. And the Kitten. is how can I say? Kitten is a language developed by Codemao, and we're using some good stuff for Scratch, but we have actually a particular design. So we have developed some more functions than Scratch. And Scratch is still kind of open source code, right? But it develops kind of slow because the new version and old version for the time between each the version update is still very long. And as a company, so we have the focus on this programming language. We're trying to design the language for education only. So in our education, we have over about I don't know like few hundred thousand students. So we learn from the children a lot of the education experiences, and then we can do the very rapid change about our programming language in the kitten. So that means we have a very good feedback loop between the students and our language design. So we also update the language very fast because as you mentioned, AI is very popular. So we design the AI modules into the kitten. But Scratch still he doesn't have the AI module so far because the new version is still a long way ahead. So I think that's the main advantage about the kitten. And the disadvantage is very obvious because a lot of people know Scratch. Scratch is open source code, and that's also easy to run as well. But Kitten also easy, but these are the basic differences. And what made Codemao to choose Python to be the computer language of the curriculum? That's also important because Python so far is one of the most popular programming language in artificial intelligence. I have been there. When I was the undergraduate, we used MATLAB a lot. And when I was the master student, we started using the C++, using the Unix system. When I was doing the PhD, I was doing the Java. And later on, when I started to work, I used Python. So you can see the process like the Python is still very new language because the like MATLAB, they have a kind of particular design functions. You can just like a NumPy or this is particular packages. You can actually import these packages and use it very efficiently. So this is very similar to MATLAB. But it's not like a C or not a Java, so you have to write everything by your own hands. So this makes this language very popular, but different from MATLAB. MATLAB is a commercial software, so you need to pay to use that. But Python is for free; it's open source. So using especially in the AI research, so Python has become more and more popular. And because they are more popular, a lot of people are trying to use that. So they add different kinds of packages and make this language more powerful. So that's why Python is kind of dominating in the AI world. Which country have learned computer science? After my graduation from China, I went to UK. So I got my master's degree and PhD from the University of Bristol. And after my PhD, I went to United States. I did my postdoc in UC Berkeley. And also I have been to Carnegie Mellon University for like a short-term research or something like that. So I have been to a lot of schools in the UK and US as well. So I can see that that's very important that so we can prepare for the future. That's because especially in California. So there's a lot of the new ideas and entrepreneurships about the using AI technology. At that time, Google was kind of dominant. So everybody is talking about some new ideas, coming to have a to have a startup, something like that. So the Silicon Valley culture is kind of very important so far. And even I think in China these years, and we're trying to push kind of new startup strategies. So basically, the government, the whole society, and even the culture kind of encouraging people to have the new ideas, and young people, especially for young people, to start their new startup and trying to do their own business, something like that. Yeah, I think that gives young people a lot more new opportunities. Yeah. The kids start learning coding with a computer, without computer. What do you think? Okay. I'm not sure you mentioned about starting learning coding with or without computer. You mentioned about the computational thinking, right? The computational thinking is actually the way we're thinking about things. For example, your boss gave you a job. It's a very big job. You have decomposed this job into pieces and to at what time to finish the first one, at what time to do the second one, something like that. Maybe you need help. This is called computational thinking. In computational thinking, maybe you don't need to use a computer. You don't have to be used. It's not compulsory to use a computer to train this kind of thinking. But if you have a computer and you do a lot of coding, and the computational thinking skill will be much improved. That's what I'm talking about. So my suggestion is still that if you're trying to learn the coding, that's the better way is to be with a computer rather than not with a computer, without computer. Okay, I think that's my final answer. Yeah. Especially if you have a lot of practice in the coding, you wrote have like over 1,000 lines of code. I think you can practice your brain or your way of thinking scientifically or thinking mathematically. You can significantly improve the way of computational thinking. That's what I believe. Yeah. So you have trained your brain to customize this kind of way to do the things, right? And when you do the coding, you have to be very precise. You cannot do any mistake, right? If you just like a comma or in a bracket, the whole program will fail. So this is also very important for the children to be learned how to think very logically without making any mistakes. So that's very, very important for children as well. A girl who's not good at math, how to learn coding? Yeah, that's a very interesting question. First of all, computing is related to math, but it's not math, right? And you can solve the equations by hand. That means your mathematical or analytical skills. But sometimes if you cannot solve in that way, you can use coding to solve the problem. And you're using another way of thinking. If you're good at math, that will make you easier to learn the computer science and the coding. But if you're not so good at math, it doesn't mean you cannot learn the computing well. Yeah, that's what I'm trying to say. So if you're a girl and if you like it, you can try very hard to learn the coding. You can find something interesting there. Yeah, because that's just a language, right? Because, for example, you find that the English culture is very fascinating. The English is a very popular language across the world. That's the reason you learn English, right? But not some Portuguese or very it's not some very uncommon language. But the coding is actually the way you're trying to interact with the machines. Suppose you learn the coding, you can actually design different kind of programs, right? You can do a lot of interesting stuff. Some stuff maybe boys like playing game, but maybe some girls like you can design your own New Year card. You can send your friend some special poem you generated from your program or something like this. You need to find out something interesting to you, and the coding is actually the way to your final goal, right? This is actually learning coding is not the final destination, right? This is not the aim. This is actually learning coding is using coding to do something useful. That's basically why we need to learn the coding. Yeah. Okay, and how should I start learning? I think that's not difficult. Depends on your age, yeah, and you can decide to learn using some graphical coding stuff or like Scratch or Kitten, or you can just start to learn the Python or C. You can write your code to see if you're thrilled by that. Yeah. So yeah, the fact is, of course, we can see a lot of the coders and programmers are guys and not girls. But I think this is just a prejudice. It never means that boys are more are more capable in learning the coding than girls, because just they have how can I say? I still have many friends doing the computer science very well. Even my wife, she's also a computer scientist, and she is actually doing just I just mentioned the AI plus the medical stuff. So she's doing about using AI technology to doing the digital pathology, and she contact with a lot of doctors, and then she trying to understand what's the real problem the hospital has, and develop some new models trying to help the doctor to make more efficient decisions, something like this. Yeah. So I think that's also very good for girls as well. Yeah. Any other questions? Yeah, I think a lot of people are trying to ask the questions about what time to learn code, right? To learn the coding, and I think you can just start right now. Yeah, to see if you like it. The kitten is actually for children. If you're adult, uh, I kind of not recommending adults to learn the coding with kitten. The kitten actually designed for children education because they are very lively. They have a lot of cartoon figures there. They have different roles, so they are kind of a particular designed for children. Kitten. And Turtle Editor is actually okay for no matter children or adults to learn the Python. It's just the editor. So we make the editor easier to access, to make it very how can I say, to make it easier to do the coding. So if you're adult, so you can learn Python using either the Turtle editor or what kind of editor is fine. But if you're adult to learn Kitten, it's not kind of a way to learn the coding. Yeah, the Kitten is kind of particular designed for children. Yeah. Oh yeah, the thing is, I'm not a kind of a frontier the first line teacher. So in Codemao, so my job is not about teaching the students, but we do a lot of things about research. How can we develop the teaching materials in the classes to make children lives, and also to let children enjoy to learning and make the learning of code a kind of a happy experience. I think that's mainly our job. So we have a lot of teachers, and teachers are focusing on the children education, trying to teach each class to teach the skills to the students. And our job is behind the teachers. We're trying to provide the teacher with the best materials to make them to train the teachers and to be make a teacher more qualified to teach children and something like that. Yeah. Any other questions? Okay. Does anyone still have any questions? Okay. Okay, thank you very much. That's the all for today. Thank you so much for sharing your talk online, and hope you can enjoy the learning coding with Codemao. Thank you so much. Bye bye.